Okay, class. For the bond Haber cycle, you will have two flowchart that you need to remember. Okay, so this one is your metal, this one is your non-metal, this one is your product lah. Solid plus gas equal to solid. So this one, okay, they have a different name. So sometimes they use the term sublimation, sometimes they use the term atomization, sometimes they use the term dissociation. All are the same meaning. So when I say atomization, sublimation, dissociation, all are the same meaning. Okay, so solid, okay, undergo atomization, it will become a gas. Undergo ionization energy, it will become ion. Okay, gas, you need to remember half X2. Okay, undergo dissociation, it will become gas. Undergo electron affinity, it will become minus. Okay, so this one is the lattice energy. Okay, this one is your product. This one is the delta HF formation. So this one is the flowchart one. But when this one, when your gas, you have two atom here. When your gas has two atom here, you need to use this second flowchart. Okay, this second flowchart, you will have two ionization energy. You have two ionization energy. Okay, all are the same. Only you will have two step of the ionization energy because you will have charge plus 2 here. And for the electron affinity, you need to double out the value. But all are the same. So you need to identify your compound. If here have two, you need to use this flowchart. If here one, you use this flowchart. So this flowchart you need to remember. Okay, so let's see the first example. Calculate the lattice of NaCl. So NaCl, this one just one. Okay, so you use the flowchart one. Okay, given the data of atomization, ionization, enthalpy, electron affinity, electron formation. Okay, so here the question asks you to calculate the energy of lattice. Okay, so class, this one you need to make the flowchart, and this flowchart will give you a total of 5 marks. Okay, so they already give you the value. So what you need to do, you need to identify the location. Okay, remember you need to use the flowchart one. Okay, so you need to remember this flowchart, and automatically you can answer this question. Okay, so solid, gas, 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 and solid. This one you need to write solid, gas because it will give you a marks. Okay, so like we know, how to calculate the enthalpy of formation is equal to enthalpy of atomization, enthalpy of dissociation, ionization energy, electron affinity, and lattice. So here we want to calculate the lattice. So delta HF is given here is negative 411. Then it's easy lah for you to calculate. The delta H for lattice is negative 787 kJ per mole. So this one is easy for you if you can remember both of this flowchart. Okay, so let's see the second example. So here, when you identify MgF2, so here F2, you need to refer the flowchart 2. Okay, so here, for example, already give you the all the data here. Okay, so you need to calculate the delta H of the lattice. Okay, so let's see. Mg F2 undergo atomization energy, undergo first ionization energy, undergo second ionization energy. This one, F2, okay, undergo atomization and undergo electron affinity. Okay, you need to times 2 because if you realize here, we have 2 steps of ionization energy. So remember times 2. And same, we need to calculate the delta H of the lattice. Okay, so same. Okay, use this formula. So you can calculate the delta H formation is equal to delta H of atomization, delta H of ionization energy, delta H of electron affinity, and lattice. So you can calculate the delta H of lattice is equal to negative 2962 kJ per mole. Okay, so class, for the Born-Haber cycle, you can answer this question only if you can remember this chart. So remember this chart, flow chart 1 and flow chart 2. Okay, don't remember, please put the condition either it is solid or gas. Okay, that's all from me. Okay, thank you.